Well, hello friends. Today we are going to work on image decoding stuff. So lately we've been adding more and more image decoders in the system. And if we look, let's see, graphics. We started with just a PNG loader, but then we've added all these other formats over time. And now there's a JPEG codec in the works as well. And this is awesome that we're supporting more and more image formats, but it also means that we are exposing more and more decoders to the internet, right? Because if you encounter one of these formats in the browser, we'll just download the data and pass it to the codec. And if one of these codecs has a bug, that bug might be turned into some kind of browser exploit. And so I would very much like to get to a place where the browser doesn't decode images in the browser process or in the web content process once we get the multi-process browser going. But even before we get there, I think we can separate out image decoding into a separate service process. So that's what we're going to work on today. But I think for GIF animations, maybe we'll skip GIFs today and do all of the static formats only. Because due to the nature of GIF having multiple frames, it might be, I don't know, it might be simpler just to start with single frame images. But yeah, that's what we're doing. So I think this is going to be a nice security and stability improvement, because if you have a bug in the, say you have a bug in the PNG decoder, right? And you open a PNG on the web, previously that would bring down the whole browser. Now it would just bring down the image decoder process and nothing else, and the web page would keep working. And of course also we'll be able to run those image codec processes with like complete absence of privilege, right, and access to nothing. So I think that'll be a really great thing. So let's call it image decoder. That'll be our service program. And I think we want to have it be similar to the web content process. So let's just copy some stuff from there. Image decoder client. Oops. And one thing that I want to do with this thing is I don't want to have one mother image decoder process that like just handles all of this work, but rather I would like it if whenever we encounter an image, we just spawn a new process. So every image is decoded in his own unique context, and when we're finished decoding, we just throw away that process. And so if you had some kind of, even if you had some kind of bug that required interaction between different images, that wouldn't work either, because every image is decoded in his own context. So double the fun. So let's see what we do here. Just doing the boilerplate setup stuff. Web content image decoder. All right, and we are not going to need libweb, but we will need libgraphics, and libcore should be implied actually. Okay, so I think that's a good start. Now let's see about the IPC protocol. And also let me unmount that. All right, so image decoder server. So what is this thing going to look like? Image decoder server will be 7001 will be the magic number. Picking magic numbers, very important. And what are we gonna have here? So the simplest, stupidest protocol would be a synchronous API that would be like decode image, and what you provide is a shared buffer, so shabuf ID, and I guess a size, or so this is like the encoded size, essentially the length in bytes of the buffer. And then it'll be a synchronous request, and it will return back a shabuf ID again, I guess, of the decoded. So this will be the encoded shabuf ID, and then we'll create a new buffer with the image decoded in it, and maybe the size of it, and whether it has an alpha channel, and maybe that's enough to start with. So obviously we could do like fancier things where you could like you could make an asynchronous request that, hey, can you decode this image? Just get back to me when you have it ready, and that would I think that would work even better. But let's just start with a synchronous API. We don't have to get fancy right away, because the current API is synchronous anyway, the way that we use it in the browser for sure. So if you look, for example, at the HTML image element, we have, wait, what do we do when we paint this? We go into layout, image, paint, and in the foreground paint phase, we call draw scale bitmap with image loader bitmap, and image loader bitmap will do a synchronous decode here, I think, yeah. So this call here will decode the image. So what we're going to do now is we are going to fashion something that still uses LibGraphics image decoder. It's just that it does it in a separate process. So I think maybe this won't be the way that we always decode images. It will just be something that you can use if you have an untrusted image from the internet, for example. But we don't need to use this to decode local images, like the icons that ship with the system. We know that those are fine, right? We don't need to protect ourselves against decoding those. But something downloaded from whatever website, it might have anything in the world in it. So that's where we need some extra protection. So image decoder main, let's see about this. So what do we do here? This is just boilerplate stuff again. Image decoder. Let me just do a search in Replace. Okay. And can we bring in these? Can we generate those headers? There we are. Okay. And then we only had the one new API, which was virtual ownputter decode image. That's the one. So it's a very, very simple API to begin with for the IPC service. And yeah, like I was saying, this is going to be a one-shot service. So you connect to the image decoder socket, and system server will spawn a decoder process for you. You send him the buffer, a shared buffer containing your encoded image, so like your raw PNG data, for example. And if everything works out, he will send you back a bitmap that you can map into your process, and that's it. So I think this is going to be excellent, but let's see how it goes. Clickety click. Okay, just removing the old stuff here from that we copy pasted from web content. And that's fine. Okay, so let's implement our decode image message. Handle. Okay, well, that's quite a mouthful. All right, so step number 1 is that this will include a shared buffer ID that we need to map. So encoded buffer is shared buffer, create with shabuf ID, message encoded shabuf ID. And if that doesn't work out, then it is an error. All right, let's log something. Could not map encoded data buffer, let's say. Okay, and then we need to pass it to an image decoder. So we'll actually have to get image decoder here. I mean the libgraphics image decoder. So image decoder, create with encoded buffer data and the message encoded size. Okay, so if message encoded, this makes me realize that we should probably take the size as a size t. Oh, the client. We need to put something in the client IPC definition. I think we may have to put a dummy message actually. So we'll just put one of these. I think we don't need anything else. The server doesn't need to tell the client anything, at least not yet. Like later when we move to an asynchronous interaction model, then we'll want to change that. But right now we'll go synchronous. But I wanted to change the this API to get a size t here. So if the encoded size is greater than the encoded buffer size, then that's not cool, because then the client is like lying to us about the size of the encoded buffer. Then encoded size, yeah. So that'll be an error as well. All right, and then will that just work? No, we didn't have that. Okay. Crap. What kind of types can we IPC encode? We can do a U32. Okay, but not a size T. U32 works for me. So that would be, again, an image decoder server. U32. All right, that's fine. Wait, what am I doing here? What type are you? Wait, why is this an int? That doesn't make any sense. Okay, that's really weird. And that's a void star, so we'll just turn that into a U8. Okay, so if no decoder, what does it mean that we get no decoder? We always get a decoder. Okay, so never mind that situation. Yeah, actually, it even tells us here that it can't be null. See, it has a deleted operator exclamation point. So, decoder, bitmap. So what will happen when we call bitmap here? It will give us null or a bitmap. Cool. So bitmap is this. Okay, and then if bitmap fails, then what we will do is, I guess we'll send a response because null is really supposed to indicate like a failure, like something went wrong with, on the protocol side. As long as the protocol is working correctly, you're not supposed to return null pointer from one of these handlers. So this means that like the client is lying to us or something like that, or something is totally bogus. In this case, if we just can't decode the image because it's not a valid image, that's not a protocol failure, so we'll have to return a response. So return a messages, image decoder server, decode image response, and the response, I already forget what it looked like. It had shabuf ID, size, and alpha, right? So shabuf ID, size, and alpha, whatever. So just something here to indicate that this is a failure. Maybe I have to say int size like this, because it can't be inferred, yeah. Could not decode bitmap from image from provided data, from encoded data. All right, otherwise we totally could. So then what we'll do is we'll just, in fact, or no, we'll just turn it into a shareable bitmap. So shareable. So we have the shareable bitmap thing, but I don't think it works in this direction. I think shareable bitmap only works, it doesn't work in responses, it only works in requests, I think. Yeah, so if we try to respond with a shareable bitmap, then it will fail because we'll send it in the response, but then we will deallocate the shareable bitmap too soon. So this is not really going to work. So what we'll do instead, we'll just do to bitmap back by shared buffer, and fix me. We should fix shareable so you can send it in responses as well as requests. Yeah. So then we will share. Shared buffer, share with the client PID. Okay, so now he's our friend, and then we will just send it over. So return make messages, image decoder server, decode image response, and then the shareable bitmaps shabuf id, the shareable bitmaps size, and the shareable bitmaps has alpha channel. Yeah. So there we have it. Is that going to be good enough? Maybe actually what we should do is we should take the image format into account. So we have a whole bunch of different image formats, depending on if it's an indexed palette format or if it's raw RGB or RGBA32, 4 bytes per pixel type format. So what I had in mind will work for these two, but it doesn't take the indexed palette formats into account. So maybe what we should be doing is passing the format to the other side and then just recreating exactly the same bitmap on the other side. That might be better. So we'll do that, yeah. So instead of sending bool as alpha, what we'll do is we'll say i32 bitmap format, yeah. Okay, so then it's no longer about has alpha channel, but it's about the format, and we'll cast that to an a32. And here that would be graphics bitmap format invalid. So yeah. This looks pretty reasonable. So now we just need to talk to this guy from the outside world. See, it even compiles. So let's add him to the system server. Much like we have the web content process here. So we'll add an image decoder process. So that will be temp portal, I don't know, image. And socket permissions can be 660, that's fine. Can be lazy, can be its own user. So image. Boot modes, definitely only interested in graphical boot mode. We'll want this to be multi-instance, and we want to accept incoming socket connections before transferring control to the image decoder program. So that's pretty cool. Let's just see that it comes up all right, but oh, actually it's not going to come up all right because we can't even connect to it. Also, we're going to need some we're going to need to add the image user to the file system. So pass wd image 16 image decoder, then false. That's great, and we'll give it its own group. So image, and anon can be in here because anon can be allowed to do this. And also web content can be allowed to do this. We're not going to work on integrate it into the web content program today, I think, but for now we'll just do it in the regular browsing mode. So that should be enough to at least bring everything up so it starts. Okay, great. Next step is to write the client side of this thing. So I wonder what would be the best way to do that. I guess we can do it as, well, this should probably be a library of some kind. So we can call it like lib image decoder. I mean, that makes it sound like it makes it sound like it contains image decoders. So I guess it could be part of libgui. It could be something that libgui offers. But we can also call it lib image decoder client. It's a very, very long name compared to the other names, but why not? Lib image decoder client. So be it. So here we'll need some stuff. So maybe we'll grab the stuff that we used in the WebView demo. Just because we started with the other side of that. So that would be in, wait, where are we now? Services. Image. Okay. And we actually want to grab a lib stuff here. So we want this to be lib image decoder client. And we need libIPC. And we also need libgraphics. Okay. Maybe I am thinking about this the wrong way. It doesn't need a main. It doesn't need a view. We needed something more like the libprotocol client. So maybe that's what we should have brought. Yeah, that's what we should have been bringing here. So let's do that. This would just be called client, image decoder client. Yeah. Deep image decoder client. Okay. And then we need to simplify some stuff here. This goes in image decoder. And you are like that. Image decoder server endpoint, image decoder client endpoint. Okay, and we only had that dummy message. All right. So nothing too crazy here. This thing just needs an API to actually decode an image. So the API will be decode image. And you will give it a byte buffer with image data. And that will be the whole API. You call this guy and he will open or he will like talk to the other side for you, basically. So I think that'll be good. Okay. Okay. And we are just getting rid of stuff. That's a no op. And set server PID response server PID. All right. Connect to temporal image. Cool. So then we have to implement the bitmap getter thingy. Decode image. Encoded data. Right. So now we need to package this up and send it to the other side. So we'll package it in a shared buffer. Encoded data size. And of course, if the encoded data is empty, then we can just fail right away. No point in trying to allocate buffers and stuff. Okay, and then if that fails, same thing. Otherwise, we will send a synchronous message, image decoder server, decode image, and then we include the shared buffer shebufid, followed by how big we think the data is. So like that. The reason we have to send the encoded data size precisely is because shared buffers, they are a kernel concept, and they the size is in increments of memory pages. So it's like divisible by 4 kilobytes, basically. So even if you have a 1 byte encoded image, it will still be rounded up to 4K. That's why we have to pass the exact size separately. So response, okay, and then if response, or hold on, format is bitmap format, response bitmap format, yeah, okay, so if bitmap format is invalid, okay, then like that. Otherwise, we'll recreate the bitmap. So create with shared buffer, bitmap format, the shared buffer, and size. So the response size. Maybe we'll do a sanity check here as well. If bitmap or if response size is empty, then we'll also return null. Because if the image is empty, we don't need it, I think. Or maybe yeah, I think it's okay. If it's an empty image, we can just say that there was no image. Maybe we'll regret this later, but for now, that's fine. And here, I guess it expects me to move it. Is that it? Oh, you expect it to be a non-null R value. Boom. So maybe we can just return this, actually. Because if it fails, all we can do is return null anyway. So that's pretty cool. Let's see if that builds. I forgot something. I left a main CPP in there, like some kind of app developer. Wait, what? I'm sending the greet message wrong. Is that it? Send sync. I should include my PID. Sorry about that. There we go. So we're still not using this library, so I guess we should actually use it somewhere. So I think we'll add it to libweb. So and maybe this should be an opt-in thing, like something that you can enable on your libweb instance, because if you're just using libweb to show like local content that you trust, then I think it's fine to decode images in process. Or, you know, maybe it's better to never decode images in process if we can avoid it for web views. For web views, maybe we should stick to using the image decoder service, because why not? So land image. So he calls image loader bitmap, and then image loader. So image loader has already set up an image decoder. Oh, excuse me. Oh, wow, I don't know what happened to my throat there. Anyway, image loader has already set up an image decoder. So I guess we want to have two paths here. One where we use the decoder and one where we, or at least for now, because we want to, like I was mentioning in the beginning, that we want to do GIF animations still in process because of the animation and the multiple frames and stuff. So we'll probably need two paths anyway. So what does the object look like? Image loader has a decoder pointer, and I think we just share the decoder with the resource object. Right, so the image resource has a decoder on it. So do we need it to work this way? I guess we'll want it to work a little bit differently. So the decoder is fine for GIFs, but for anything else, maybe what you would do is ask for a bitmap directly. So something like, I don't know, like this. And what would that do? It would be, or actually it would have to give you ownership of this thing, because we're not going to hold on to this right now. So this will be, or once we have decoded an image, it's okay to cache it. So we could take ownership of what we decode. Decoded image. And we'll make it mutable so that bitmap can lazily create it on first call. So okay, so this is starting to come together here. So if we have no bitmap, no decoded image. Okay, so then what we'll do is we'll grab the lib image decoder client. So we'll have one of those guys, and then we'll instantiate one right here. Decoder client, image decoder client. Image decoder client construct decoded image is image decoder client decode image encoded data. No? Can I get it like that? Okay, here we go. I think that's it. Okay, and then of course we need to call this. So maybe what we'll do is maybe image resource. Ultimately, the best approach here might be that image resource takes care of fetching the all of the frames, because right now the reason that we keep the image decoder around is for GIF images and stuff, so that we can fetch one frame at a time, and then we let the decoder cache everything. But maybe a better approach is to have the image resource class in libweb manage all that stuff. So we would just create whatever decoder, whether it's an out of process decoder or an in process decoder or whatever, but it would create its decoder instance and then get the frames that it wants, and then be rid of any decoder from that point, and only like instantiate a new one if it's ever necessary. But I'm not completely sure how we're gonna do this, so we'll just keep rolling. So where do we use this? Ensure decoder. We use it in image loader, and so let's see. I guess what we do here is we pre-decode to figure out if it's animated, and if so, we do some stuff. That's the only reason that we immediately decode on resource load. So I think one thing we could do here is can we, do we know the MIME type? If resource, let's see, if resource, let's let's say is GIF. Should decode in process. Yeah, and then we'll do this, and then we can get rid of this hack once we figure out what to do with GIFs. But for image resource, we'll have something like that. So should decode in process. And how will we respond to that? Image resource should decode in process. Return MIME type is image/GIF. Is that the right? I guess that's the one that we would find. Okay, great. Guess MIME type based on file name. Fancy. Okay, so then let's see, where was the other place where we called ensured coder? Didn't replace. Okay, so if resource should decode in process. Okay, and then here, wait, who calls this guy? This is such it's a little spaghetti-like. Not very happy with that. But this gives us reasons to make it better. So if resource should decode in process. So if we have a resource and we should not decode it in process. We'll call resource bitmap. Wait, why don't we move all of this there? Actually. So return null footer, otherwise return resource bitmap, and then in resource bitmap we will do all of this stuff. So if should decode in process, do this stuff, else do this other stuff. And we need to give him the frame index, right? That's fine. So this is a little bit hazy, if this is going to work right. So let's see who grabs directly at the image decoder. Image element does. He has an accessor, but who uses that? Wait, is anybody using that? Layout image calls image loader image decoder. Image loader calls. Wait, so nobody actually uses these? So they can just be removed? Let's try it. That's great news. We're gonna have to figure out what to do with that. So one less image decoder. Okay, object element. So layout images, they check with their image loader right. And then image loader has a decoder, but image loader also has a resource pointer. So I think we could go directly to resource and call bitmap on the resource, and then we'll end up on the same path. Let's just see if this thing starts up at all. So okay, so this didn't work out perfectly. Did we need to print some stuff somewhere? Actually, no. I guess that's actually the layout image, which tries to render via the image loader bitmap. And image loader bitmap goes to resource. Right. But he will think that he's an alt text image if we don't have a decoder. Let's put something else here. So instead of asking for the image decoder, we'll say can image. That doesn't make any sense. Can has image. Ugh. Okay. And then has image is a little bit more nuanced. So what does has image check? If resource, if there's no resource, then by golly, you certainly cannot have an image if you don't have a resource. But otherwise, if resource should decode and process, return image decoder. Otherwise, let's just say true, I guess. Okay, so who else calls this? Still at layout image, but now it's only for finding the width and height. I mean, that's still important, because I think temp portal image connection refused. Okay, well, that's a start. It's there. I am not in the image group, so I can't connect to it. Wait, I'm not? I am in the image group. What am I talking about? Connection refused. Why? Maybe, oh, because it hasn't been unveiled. Oh, of course. So browser main, we need to unveil the image decoder portal so that we can access it. That'll be a good thing. Okay, and then what happened? Operation not permitted. We're not allowed to map the bitmap because I'm probably forgetting to share it with the other side. When we call decode image, before we send it to the other side, we need to share with server PID, and I guess we could make it immutable because why not? Don't need the, certainly don't need the image decoder service modifying our encoded data. Like, there's no reason for that. Okay. So what happened? We have something crashing. Great. Okay, so taking over the accepted socket, sure. Could not decode image from encoded data. Why not? Could not decode image from decoded, or could not decode. So what did that mean? Okay, so decoding failed. And then we have some kind of use after free right after that, which is not very tasteful. Why do we have that? Train messages from client. We are at plus 35, so is the socket gone at this point? Are we calling this on a dead object? That's a bit gross. So let's do something goofy here, like I don't know, something like this. I think maybe this function is deleting itself, or the object is being deleted while the function is still running or something. I don't know. I don't want to look too closely at this. Just see if we can patch over it real quick. No? Okay, well, something else is wrong. I'm just going to ignore that and try to work out why the decode doesn't work instead. Okay, so I guess we'll have to look at what the encoded data is that we're getting then. So, trying to decode message, encoded size, bytes of image data. In shabuf id message encoded shabuf shabuf size is, what is the shabuf size? It's the let's find out. Okay, so why are you crashing? Why? Trying to decode this many bytes of image, so does that match our test image that we were using here? 213226 bytes, that's exactly the same number of bytes, sure. And then it doesn't successfully decode. Why is that? Wait. Am I just sending over zeros? I'm creating this thing, but I'm okay. I need to actually fill that buffer with the image data, otherwise nothing cool is going to happen. So I'm just trying to decode a bunch of zeros. So const void star is the encoded data and encoded data size. Okay, and then of course now we're like copying the data before sending it over, but as this matures, we'll figure out a way to plumb like the same shared, immutable shared encoded data buffer from one side to the other, so that we don't have to do a copy. But right now, making a copy is fine. Okay, now what went wrong? Trying to decode, and then it didn't complain, just the client disconnected. The client disconnected and that's it. Well, I guess we're gonna have to deal with this, because if the client disconnects, that's not the end of the world. Why is it complaining about that so much? Client disconnected. Let me call die. Which removes the client connection from here. So probably the destructor will run. We return right after. That seems fine. Wait, so why would that be a problem? Drain messages from client. Are we ending up there again? I mean, I guess when we disconnect here, we don't only want to die, but we want to actually like kill the whole program. So like that's fine. We don't need to stay alive. So that's good. What happened here? Image decoder starts up, takes over a socket, and then the client disconnects and everything is good. And it gets reaped by the system server. Now the big issue is that we don't get the bitmap. Presumably we have the bitmap somewhere because we asked for it, but we're not using it for anything. So image, let's see, image decoder client. Who calls this? I already forgot. Image resource, right. Remote decoded image, and then let's say, can we do that? Does that actually do anything meaningful? Probably not. I mean, it's just a pointer. So let's say, let's do something like that. If we can see what the dimensions of the image are, then we're on the right track. So remote decoded image is 455 by 1000. That's great. So we have decoded the image remotely. What else do we want to do here? So ensure decoder. Who else is calling this now? It's really only if it's a GIF. That's good. Layout image. Wait, so is the problem now that our image is like bogus size or something? If we bring out the layout tree here. Our image is 0 by 150, right? So we're not getting the dimensions correctly in layout image because we're asking the image decoder. So we need to ask the image loader instead. Preferred width. Yeah, preferred width. Or okay, just height. Something like that. And then this guy, Mr. Image Loader, he needs to have some functions for that. So width and height. So how do we compute these things? And why do I think they should return bool? That doesn't make any sense. Unsigned bool. Okay, so the width, it's the same awkward story. Like this is going to be awkward until we get rid of GIFs. Like this is going to be a little bit awkward because it has two modes, like in-process decode and out-of-process decode. But it's okay for now. So if no resource, return 0. If resource should decode in process, return ensure random image. Oh, wait, hold on. If we have one, then ask him for the width, otherwise 0. Yeah, and then otherwise it's bitmap. If so, bitmap width, otherwise 0. Okay, so that's kind of roundabout and awkward, but I think it'll be okay. Certainly making more calls than necessary here, but okay. And that's a crash. So why did we crash? We crash in trying to blit this thing. Crash when trying to blit all things. So we have a read from address. Okay. And that's an invalid address. So wait, does that mean that this address is no longer mapped by us? Crap, wait, what did we do for that once we got the image? Image decoder client, image resource. So after we got the image back, decode image, we did create with shared buffer, but who holds on to the shared buffer? Presumably the bitmap will hold on to the shared buffer, right? Create with shared buffer. New bitmap. Shared buffer moves into the bitmap. Right. And then we don't lose it, because that would be super annoying. Wait, so why is the bitmap data gone? I don't understand. Can we... Let's see what we can learn here. So in here, we still have the shared buffer on stack here. So we'll just say bitmap is this. Created remote decoded bitmap from shbuff-id bitmap shbuff-id original shbuff-id was the one that we got from the other guy, so that would be the response. Oh, wait. Oh, yeah. This is stupid. I'm using the encoded data for my decoded image. I'm not mapping the thing we got back from the other side. So this here is the encoded buffer. And then what we want to do is we want to have the decoded buffer. That's why it's good to not, if you have two buffers, it's good to not have generic names, but like specific names for both of them, right? Because then I would have been writing this out here, encoded buffer, and I would say, oh, wait a minute, this doesn't make sense. So we need to get our decoded buffer now. So decoded buffer is shared buffer, create from shbuff-id, response, decoded shbuff-id. Right, and if that doesn't work out, return null putter. Yes, I think that's good. Seems like we're loading decoding the same image a bunch of times. Oh my goodness, it's every time that I do this. I guess something doesn't go super right. And it tries to decode over and over. So as you can see here, by the way, like decoding out of process is clearly quite a lot heavier than doing it in process. So it would be a disaster if we had to decode, like whenever you're resizing like this, like if we have to decode over and over and over, the cost of doing that is too high. But I think it's going to be okay if it's just once per image, right? And then if this becomes a performance issue, then I think we can analyze that and like investigate where we can improve things. Like I would rather get this sort of security architecture in place as soon as possible, because it's better to have a secure base architecture and optimize for that rather than trying to like put secure architecture in later. It's just better to get it in early, because then your optimizations are more meaningful in the long run, I think. Anyway, why is this doing this to me? Is it that it fails? So shabuf get is failing in browser. It might be this one that's failing. Debug. Could not map decoded image shabuf. Maybe that's the problem. Indeed, we could not get map it. So it's an EN valve for shabuf get, which means we're probably dealing with a shabufid that's no longer there. And that's probably because, or wait, why would that happen? Oh, it's because decode image, no, this is decode image. I was thinking that we disconnect before this is done, but I think we disconnect after this point. So the remote side is still alive, but what's wrong with 64? This is the thing that no, that's what he's trying to decode. Okay, so we need to print out what we're trying to map on the other side. Here, response, decoded shabufid. It would be nice to get shareable bitmap working in both directions, actually. Although it's not quite powerful enough for this use case anyway, but still. Could not map decoded shabufid 63. Why not? Is it because when you send it to me on the other side, you've already unmapped it by the time I get it? I bet that's the problem. So let's fix that. Yeah, that's going to be the problem. So he sends us a shared buffer from the decoder side, and that's this shared buffer. Where is it? It's the one right here. And then this thing goes away. Oh, so we create a message, and it has the shabuf ID, but by the time our peer receives the shabuf ID, this thing has gone out of scope and been destroyed, and the last ref was removed from the shabuf, and the kernel just deleted it. So we're gonna hack it and do this, and we'll make it a member, and then we know that it will stick around. So ref putter to graphics bitmap, shareable bitmap. All right. It's just a hack to hold on to it a little bit longer so that our client can map it. And there we have it. Now, isn't that magical? We just decoded that remotely. Very cool. Let's go to our home thing here and try some BMP test suite. Oh my god, look at all this. It's very noisy. Wow, that was not super successful. Is indexed. Okay, why is that going wrong? Create with shared buffer, blah, blah, blah. We can't do indexed bitmaps with shared buffer. To bitmap backed. Why is it like that? Who complains about that? Is indexed bitmap 1, 2, 3. Well, why couldn't we map a shared buffer with index data? Like, there's no reason that we couldn't do that. I mean, it's a little bit unusual, but let's just allow it. See what happens. So that PNG suite, or the BMP test suite there, it's very noisy. All of this debug output is really too much. And here we go again, right? So this is the sort of thing I was saying, that like we can build this architecture nicely, but it's gonna have some performance issues probably. Oh, here we died out of kernel memory. Yeep. Why is that happening, I wonder? Out of kernel memory. Temp fs. What are we doing in temp fs? Open, create inode. Oh shit, is this RPC sockets in temp, perhaps? If so, that's pretty weird. Let's see. I think maybe that's that. Let's disable those. If we don't have the RPC server, like, that's fine. Take up. So these are already too noisy. At least let's get rid of some of that noise. Probably we should get rid of all of this noise. Like these things, this is debugging information, right? So what do we have? This is still too noisy gonna be, but at least maybe it will run all the way, we'll see. So we should put this thing behind the flag. Something like that. And, oh, I guess like that then. Yeah, and then there's a whole bunch of other debug information. Service debug. Spawning, also very noisy. What else is noisy? Okay, well, he's still going, so... Wow, look at him go. I wonder if he's going to succeed in decoding all those bitmaps. This is clearly clearly not acceptable performance. Like, you don't want the browser to hang for this long, just because we're loading a whole bunch of images, and then we ran out of memory again. So I would think probably we're leaking something as well, and this just exposes that because of the extreme pressure that it puts on everything. So let's see. But that's really good if we find things that cause resource leaks in the kernel. Haven't been looking at things like that for a long time, although this is probably the most extremely stressful thing I've done to the system for a long time in terms of putting load on the kernel. Do exec. Unblock due to signal, right? So like this information is not, it's debug information. Scheduler debug. Do exec. Like these things are all debug info. Oops. All right. Just removing a little bit more gunk. I want to take a look at the system monitor while we're doing this. So this is really weird, right? Like, it's mentioning, it goes quite long in between mentioning individual images. So what the heck is the system doing so much? System server is really busy. We should get a privileged version of this. Hello? So what on earth are you doing, system server? And there's a crash. Trying to get a backtrace. Oh, kernel faulting in recently k-freed memory. Ugh. That's not good. Why is everything going so weirdly? Wow, I had such ambitions for this, and now it's going in such a weird direction. So here, for example, we load that PNG just fine. Bounty program. Yeah, that works fine. Sponsor on GitHub, that works fine. Yeah, so for like normal content, it seems to work pretty fine. And I don't know what happened with our eyes image here. But it seems to be working pretty okay. But what on earth is happening? Also, why is this so sluggish? What are you doing, system? Okay, so I guess let's go to that bitmap test suite. And I just want to see what somebody's up to. System monitor, sure. What about system server? That's what I want to know about. And we died again. There's pretty weirdly crashy kernel situation going on here. Okay, I guess I should show you what that page is supposed to look like. Oh, it's not there. It's like this. It's a bunch of BMPs, but it's not like an unreasonable number of them, just a bunch. Which makes me wonder what the heck is going on with that. I guess one option could be that one instance of, like we would keep an instance, a connection to the image decoder service per process. So like one browser would open one connection to the image decoder thingy, and then if it dies, we can open a new one. That would maybe sort of work. So it would still like serve only a single client, not have multiple clients. Then you would lose the architectural benefit of running every decode in a pristine space, but maybe we can gain the ability to at least do anything at all. So I wonder how the birthday page would look like. Like this one has a whole bunch of images on it. We can see it decoding pretty fast here. So this seems to work really well. There's something about those bitmap files, it just goes bananas. And they're local files too. Why is it eating shit when opening this? I don't understand. Oh, now you just keep going like that? What? Okay, what are you doing? Hello? I exited the browser? Why do you keep doing whatever you're doing? Please let me use the mouse. Okay, this thing is not healthy. I don't know what's going on. And these bitmaps are tiny. It's like 1 kilobyte. I have to go and look what if we just try to open them in the file manager? Like, does that also tank completely? Res, HTML, MISC, bump suite. So the thumbnailing thingy just thumbnails them like no big deal. Can we do this thing? Okay, that doesn't work super well. Wait, are we actually... Yeah, this is loading different ones. Okay. Interesting artifact. I'm hovering these. I guess it's because of the alpha. What the actual heck? So these loaded nice and smooth. That's good. These guys too, nice and smooth. So it's really just the BMPs then. Could it be when we fail that something goes goofy? I guess we should log that something fails. Because I think it does have decoding failures, but that shouldn't be such a big issue. Image decoder, image resource. When this does not go the way we want it, so if if undecoded image, or let's say something in here. Response image was empty. I don't know, let's just log something for each type of failure so we can see if something goes wrong. Was invalid. Could not allocate encoded shabuf. Okay. Created a bitmap with size. Okay. Something is just going obnoxiously wrong here. I just don't know what it is. Maybe it's that we retry the decode for every failed image over and over and over, and we don't remember that it fails. Is that it? Encoded data is empty. Well, that's suspicious. Certainly seeing a lot of that. Okay, so let's ignore that one. Although, why is it trying to decode an image that is empty? Why are we trying that? Calling bitmap on something that... Oh, hold up. So we're calling bitmap on something even though we don't have downloaded data yet. And then even though we don't have downloaded data, we're still making a connection to the image decoder service. So here, I think we should check first if we can check early if encoded data. If not has encoded data, then return null. Okay, yeah, because like this explains why we had 4,000 processes, right? Stressing the heck out of the kernel. And it's good that we find stress issues at the kernel, but it's not good if it just totally murderizes what we're trying to do. So there we had a crash, but we made pretty good pace progress on these though. So what happens? It's a null pointer deref. We're trying to blit an image that is not there. And it's a draw scale bitmap from layout image, layout image, draw scaled, this guy right here, calling m image loader bitmap. So I guess we'll do something like this. If bitmap is that, then get Mr. Bitmap. Why would a valid bitmap pointer have null data inside of it? That doesn't make super sense. It does not make super duper sense. Okay, this is closer to the pace we're looking for. And then we die again, probably because of the null pointer deref in paint. Why? Okay, so let's clean up some of the... Oh, response image was invalid. Okay, that's fine. response image is invalid. We don't want to try this again. So we need to learn our lesson if this fails. So that's one thing here, that if this fails, whatever happens, we'll say like M has attempted decode true. Okay. Oh, that needs to be mutable. But generally, I think that's fine, because then, yeah, then whatever happens, we'll remember that we tried, so we won't try again. Because if we look at the output, it looked like he was trying again and again the same broken image. Invalid, 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 and so on. Trying to decode. Okay, that was a quicker failure, still failing though. Could not decode. Yeah, that's also like that. All right. Okay, I guess we need to figure out why this is doing that then. Layout image, draw scale bitmap. Do you have a null scanline putter? Is this an empty bitmap perhaps? If bitmap size, wait, let's log what kind of bitmap we're blitting. Layout image, painting a bitmap with size, bitmap size, scanline 0 is, just see what the pointer to the first pixel is. Click. Okay, and this is crashing. It has a valid scanline pointer. So that's a bit surprising then. Why is this failing? Am I looking in the wrong place? Drew successfully. And now we're getting scientific here. Let's do scanline last as well. See what that one is. So bitmap. Scanline. Height -1. All right, so let's just see. I just want you to tell it to my face browser. Wow, look at it go. Ah. Drew successfully. And then this one does not draw successfully. But why the null pointer? I don't... These addresses are not null. Are we trying to write to null? No, we're trying to read from null. Okay. What on earth is the problem now? I mean, we're gonna have to figure out what's going on, but it's really weird. So draw scaled, we'll just call blit in our case, because we're dying in blit. And there's no alpha or opacity going on, so we just... Oh, wait, back up. Oh, hold on. It's an indexed bitmap, of course. But... Are we forgetting to... Oh, shit, maybe we're forgetting to set a palette. We're not copying the palette over. Oh, yeah, that's true. We need to include a frickin' palette. How do we transmit the palette then? I guess we have to send it on the side somehow. So this should really have a more graceful failure, because I guess it's calling like palette, indexing into mpalette, and then mpalette is null. So really, we should probably say here like assert mpalette. It's not called mpalette. Oh, assert bitmap. Wait, what's it called? Source? Palette. Can I see the palette? I can't see the palette. Wait, so who allocates the palette anyway? I guess this is probably why we have that assertion that you can't create an indexed bitmap from a shared buffer, because we wouldn't have the palette data. So in this case, that's my bad. So we need to transmit the palette somehow. Create. So that was this the guy right here. Yeah. So we'll make an alternate constructor that's the same, except it also includes the palette. So what would the palette look like? It's mpalette is equal to, then we do, the largest palette is, it's just an RGBA 32 array, essentially up to 256 entries. So RGBA 32 palette, yeah, that'll be our alternate constructor. So, or actually we can even have it be the same constructor, const RGBA 32 palette, and so be null putter by default, or yeah, that's fine, or no, that's not necessary because this is a private constructor anyway. All right, so let's not do that, and then either it's not indexed or we have a palette. Yes, everything is starting to make sense now. We need the palette data. Mpalette. We need to make our own copy of the palette. So how did we do that here? Allocate palette from format, right? So if is indexed, allocate palette from format. Is indexed. Wait, what's wrong with that? Oh, do I have to say format? Yeah. And then mem copy from, or to my palette from input palette, and then size, oh wait. We need to know how many things to copy. I guess this thing could have, let's see, this thing could have an optional source palette thing, and if you provide that, we will copy out the data. Okay, and we are super good boys. And then we just need to provide the palette here. Okay. That is great. So next part is actually transmitting the palette. So where do we stash the palette? It's gonna have to be, it would have to be either a separate buffer, a separate shared buffer, but I think that's kind of, that's a little bit heavy-handed. So we could also just use a vector of RGBA32s in the IPC layer. So let's see how we would do that. Image decoder server, it would respond with a vector of U32 palette. Yeah. And decode image response, we need to actually include a palette there. So in the invalid case, it's just an empty vector, like that. And in this case, it's the palette. So our palette here is a vector U32. If m shareable bitmap is indexed, then we need to get the palette as a vector. How do we do that? Let's add a helper for it. Vector RGBA32. Palette, this is vector. Palette to vector. Yeah, something like that. Also, this stuff is so awkward. Like, this whole number thing here. Like, we can also put this in a helper, like palette size, right? For a format. And then we just say switch format. Case this one, palette is 2 entries. And then we have indexed 2 and 4 and 8. And default is cert not reached, because we shouldn't be asking that about a non-indexed size. And then we 16 and 256, because then we can just ask for the palette size for the format and copy the palette size entries, and then it becomes a matter of doing that instead. And then Likewise down here. Let's just make sure that we grab, maybe we'll put this upstairs in the header actually. Clickety-clack. Oh, you can go next to your friend here. Okay, and then this guy just has to make a vector of RGBA32. And okay, vector append, actually vector ensure capacity size, and then we can do unchecked. Append with palette color I. Does that not make sense? What's palette color? Oh, it's a color. Oh, I see. Okay, it's a value. There we go. Palette to vector. Cool enough for me. And then palette is shareable bitmap palette to vector. Oh, this is awkward that this thing doesn't. We should just have an overload like this that is non-static. The checks is indexed for my format. Wouldn't that be nice? Okay, so now I need to, I need to sling in the palette. So here, create with share buffer. I guess we should have passed in a vector of RGB32 here, actually. Although this thing needs to be optional. Otherwise this will break in so many places. So we can just do something like that, and then we'll make the this guy have an alternate version. Palette, and the constructor gets a vector instead. We don't have to rely on social contract to not have too many entries in that place, in that vector. Okay, and then the palette, set index, or palette is non-empty. And then, allocate palette, likewise, we'll take a vector. All right, and then we can assert that the source palette size is the same as palette size for the format. Tick. Size, source palette, data. Oof. There we go. So, allocate, we need to change his signature. Okay. Wow, this is a little cumbersome, but it's gonna be okay. We just need to update those calls to pass an empty vector if we have no palette, which is fine. Goodness. Well, this is taking a moment, but I feel like we're certainly discovering a lot of interesting things. We'll see how this turns out now. I guess we have to rebuild a bit because I was messing with bitmap. It shouldn't take too long though. So where are we in terms of diff? Ooh, chunky. All right, let's do some like silence debug spam diffs. So do that one, kernel, silence some debug spam in scheduler. And same in process. Kernel, silence some debug spam on exec, sysexec, or really it's on exec. And then we have stuff in system server, so diff cache. This is really just putting some stuff behind. Put some debug spam behind if defs. Core put safe syscall debug spam behind if def. I think debug spam is fine to have, but like the moment it starts to get in the way or get annoying, you should just put it behind a flag or remove it, right? Because we don't want to accumulate so much debug spam that you can't see the thing that you're interested in. That if that happens, then we just have too much debug spam. So it's always this like ebb and flow thing where you add debug spam and then you let it sit there for a while and eventually it becomes annoying and you scale it back and you'll go back and forth like that. Something went really wrong here. Allocate palette from format fails. Okay, allocate palette from format. Oh, because what if I don't have a source palette? Yeah. If source palette is non-empty, we only care about that if it's not empty. If we have an empty source palette, that's just the normal bitmap creation path. Okay, and now what don't you like? Assertion failed in bitmap H129. Oh, because now, wait. Allocate palette from format. We're always calling that? Oh shit, we're always calling that. So in that case, I guess we should just return 0 in this case here, and then if size is 0, turn, and not allocate a palette. Great, now we have to rebuild a bunch of stuff again, but that's okay. So what else do we have here? Do we have some stuff that we can bring with us? So that's some debug spam. So let's grab those two guys. Core, remove some debug spam in local, server and socket. Okay, and then I disabled the RPC socket, but I'm just going to put that back because I want that thing. So let me start the build over just in case. And then none of this stuff that we have remaining is really like standalone anymore, I think. So the rest is all interdependent. I mean, we could add the image decoder service, I guess, by itself. And a libimage decoder client. That would be fine. That name is really goofy. Maybe we'll come up with a better name later. But I think it's okay, so. So we have to add those, and then we also need the bitmap changes for this. So let's see that they work first. I mean, we're not, even if they don't work, we're still going to commit what we end up with in the end, so we can still add them to the staging commit thing. Oh, what did I change here? Oh, that would have been a fine separate commit. All right, let's see this. Come on, BMP test suite. No, still not. Source palette size is not the same as size. Okay, well, that's at least an interesting problem. So how big is the source palette then? Source palette has source palette size expecting size. That's a little bit of a weird problem. So either we have too many or too few. But it's a non-zero number, which is the interesting part. So how do we end up in that situation? Source palette has 0 expecting 2. Oh. Oh shit. It says is empty. It's supposed to be is non-empty. That's my bad. Man, that whole thing where like the kernel just goes very red-faced if you spam it with processes, that's not really good. We should do some stress tests and stuff sometimes. Either is not indexed or palette is non-empty fails. Bitmap CPP 123. So either you're not indexed or palette is empty. So presumably we are indexed. With an empty palette. How would that happen? So if is indexed, indexed with palette size, palette entries. I just want to know what's happening. More printf debugging, but that's how we will learn. Oh, wait, back up. Are we not passing the... Wait. I added this overload, but I think I never actually use it, or I didn't implement it. So nobody's calling this. So this just needs to do the same thing this guy does, except pass along the palette. And wait, what don't you like about that? Oh, of course, I need to name the arguments. Clickety-clack. Palette. Here we go, then that thing is not going to be a problem anymore, and then we just need to make sure that we call the right one from libImageDecoder client. So we need to call the one that has the message, the response palette, which, you know, could be empty, could be non-empty, but it will have the palette. And now, I think it should actually work, but we'll see. Ah, I spoke too soon. Okay, so we're here again. Why is that? Did I make a dum-dum? response. Let's see what was happening here. So response palette size. Or we're actually saying created bitmap with size. Yeah, okay, so we can include that there. Just because that will be interesting to see how many colors we have in the palette. And I should stop pre-celebrating the success at this point because we keep running into different issues. So, 0 entries in the palette. Did I just forget on the other side to actually send along the palette? Is that what's happening? Palette to vector if it's indexed. Okay. And palette color grabs the palette color, that's fine. Palette size. Oh wait, does this throw away the palette already here maybe? Maybe this function doesn't, because we're calling this function to make sure that we have a bitmap that's backed by a shared buffer. So this may actually create a new bitmap. It will create a new bitmap, and then that bitmap does not copy the palette of the old one. Right, so we could actually send in the palette here. We send in my palette to vector. Okay, so I think we were sending the code to send the palette across is correct. It's just that we were losing the palette in an earlier step of bitmap conversion on the service side. And finally, we actually render. At last. At long last. Man, that's very pleasant. Okay, so let's get rid of all of this irritating debug logging that we added. And I have one of those somewhere. I have those many places apparently. That was probably, was it here? Created bitmap with size. Okay, so you can finally look like this. Wow, this whole process took like about an hour longer than I was expecting, but I guess it's good to get schooled on how everything works. Oh, what happened here? Oh, it's just a bunch of missing images. Okay. So resizing is actually a little bit sluggish. Well, it's probably some libweb issue that we can debug separately, but that's interesting. Those types of problems are usually pretty fun to work on. That's awesome though. So now this stuff actually like unironically works. And I would say the BMP test suite, it's like, oh, now they were cached. So I was going to say it's like it takes its sweet time doing the initial decodes, but maybe it's not so bad. Response image was invalid because if we don't have all of this output, there's so much spam here. Such spam. And has encoded data, also very spamish. Okay. Okay. Yeah, because this is fine. Like that just means that the image decoder determined that, or could not decode the image, but it still exited successfully. So what if we get a lot less debug output? It loads pretty fast, yeah. So that's cool. I think for synchronous performance, this is pretty okay. If we're going to switch this over to asynchronous eventually, I just wanted to build the first version synchronous, just because it's easier to get it working. So now we've achieved this. And then future work will be to make this an asynchronous service where you send it a request to decode an image, and then it responds whenever it's ready with that, because then the libweb browser process does not have to block waiting on the image decoder server to respond, but it can do other stuff, and like it can actually be responsive. But yeah, this is awesome progress. So let's just make sure that we include that and that. So let's commit and say image decoder. Add a new service for out of process image decoding. The new image decoder service available for members of image via temp portal image. Allows you to decode decode images in a separate process. This will be very useful for things this will allow programs to confidently load untrusted images, since since the bulk of security concerns can be sandboxed into a separate process. Sandbox to the only API right now is a synchronous IPC decode image call that takes a shbuf with encoded image data and returns a shbuf with shbuf plus size palette for the decoded image. I'm forgetting, is that everything we had in there? It's the shbuf size format and palette, right? So, but like it's not the returns a shared bitmap. Shared buffer plus metadata for the decoded image. The overhead, there's it also comes with a very simple library for interfacing with image decoder service. Lib image decoder client. Name is a bit of a mouthful, but I guess we can rename later if we think of something nicer to call it. All right. Oh, I wanted to say that the overhead, there's obviously a bit of overhead to spawning a separate process for every image decode. So this is mostly only appropriate for untrusted images, e.g. stuff downloaded from the web, and not necessary for trusted local images, e.g. stuff in res. Okay. And then we'll do this one. Lib IPC, silence some debug spam. And then I will say, wait, does this break every other libweb client now? Because I feel like we're breaking stuff like the text editor, because now he needs access to temporal image as well. Although text editor does not unveil, so maybe that's okay. Like here, this will download a screenshot, and yeah, okay. So this downloaded a screenshot, and wait, what actually happened? Did we actually run an image decoder service? I don't even know if we did now because it's so quiet. But yeah, we must have done that. So that works just fine. Yeah, so if you're using libweb now and you want to be able to show images, you need to allow it to connect to temporal image. But that's just a matter of unveiling that, so I think that's fine. Okay, great. So libweb plus browser. Use the image decoder service to decode images out of process. Or let's say decode non-animated images out of process with image decoder. Okay, I can't fit that. Okay, so we now use the image decoder service in the web for everything except GIF images. We'll have to deal with them later, of course. This has a little bit of overhead, but I think we should be able to optimize it until it becomes negligible. Yeah. Super awesome. So, are we forgetting one thing now, though? Are these pledges that we have for the image decoder? This thing here is silly. Like, it doesn't need to connect to the protocol server. That's just because I copy pasted web content. So let's get rid of that because it was a copy paste, and it also does not need res either. Like, this thing does not need much. It doesn't need RPath. It doesn't need to make outgoing connections. it should already have an accepted socket, and it shouldn't need any file access. So I think this should be able to do its work with this super tight set of things. But I guess I missed something. What did I mess up? Has not pledged Unix. Okay. What are you trying? You're trying to do some get sock opt and that fails? All right, fine. You can have Unix then. Maybe we can drop Unix after we instantiate the connection. All right, it still works. That's so cool. Because now this thing is very, very, very slim, right? Like he has access to basic I/O and shared buffers. Can't do anything else. No file system access whatsoever. This is very, 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 very tightly restricted process. And I think this is awesome because this means that we can now feel quite confident when viewing images in the browser because those images are not being decoded in the browser process. And if there's any bug in our image decoders, they will crash or, exploit the image decoder service process that was spawned for the decode. But even if they take control of that process, some malicious whatever takes control of that, it still can't do anything because it will only have standard I/O access and shared buffer access. And the only thing it can do IPC-wise is to send back an image to the browser that would be like a bad image, right? Or maybe like an image that has something wrong with it. But even so, like it's very limited because we will not interpret the data coming back as anything other than an image. I mean, there might be bugs obviously here, but we've reduced the surface area quite drastically. So I'm really, really happy with this. And yeah, the performance is definitely a concern, but it's something that we can improve over time, I think. Yeah, I mean, it loads really nicely. It's like you don't even think about it. Yeah, it's just great. So I think we'll commit that. We're probably going to squash that one into... Should we squash it? It's just a fix-up for... it's a fix-up for the image decoder here. So I learned about fix-up. It's like squash, but you just get rid of the commit message from this one. So thank you to whoever suggested that. Boom. Okay, so I think that's going to be it for today's video. So if you made it this far, then I thank you for watching, for hanging out, and I hope that you saw something interesting. I think this type of stuff is very interesting. We certainly hit a lot of hurdles today, but we came out victorious at the end, and now we can load images in the browser and not worry about PNG decoder exploits and stuff. And yeah, we'll have to deal with the GIF images somehow, but I'm not going to do that right now because this has already been taking so long. So thank you all for watching. I hope you liked it, and I will see you next time.